The Last of Us TV series is probably one of the most notable aberrations in pop culture, a game-based live-action adaptation that truly worked. One of its coolest concepts is the Cordyceps infection that transforms humans into rotting, brain-dead, feral zombies. Just imagine inhaling endless fungal spores, each breath feeling like icy tendrils creeping through your bloodstream, binding your nerves and rattling the edges of your sanity. Soon, every exhalation sparks an agonizing transformation, as the relentless fungus usurps your mind and body, unraveling the familiar self into a haunting, twisted echo of what you once were. Yikes. Anyway, coming back to the point, Cordyceps is shrouded in mystery, having always been kept in the shadows in both the series and the games. In this video, we're going to answer all the major mysteries surrounding the infection that were never explained in the Last of Us TV series or the games. Let's begin. Before we go into our explanation, we have a very small request. If you like our content, please support us by subscribing to our channel. This is a small click for you, but for us it means a lot. Thank you. Let's begin. What caused the initial mutation? The initial mutation of the Cordyceps fungus, which allowed it to infect humans and spark the catastrophic outbreak in The Last of Us, is a central mystery of the franchise. While the games and HBO series offer hints, a definitive explanation is never provided. However, several plausible theories emerge from the lore and real-world fungal biology. In the HBO series, the outbreak is traced to Jakarta, Indonesia, where mutated Cordyceps spores contaminated flour at a grain factory. This flour was distributed globally, infecting millions through common food products like bread and cereal. The mutation itself is attributed to environmental changes, particularly global warming. In the show's opening episode, a scientist warns that rising temperatures could force fungi to adapt to survive in warmer conditions, including human body temperatures, 37 degrees Celsius. This aligns with real-world concerns about climate change enabling pathogens to cross species barriers. Another speculative theory involves a viral or parasitic interaction triggering the mutation. In the game's lore, there are suggestions that a virus may have altered Cordyceps structure, enabling it to infect humans. This parasite for a parasite scenario mirrors how some viruses can manipulate fungi in nature, potentially accelerating evolutionary changes. The mutation may also have been facilitated by industrial agriculture. Flour factories provide an ideal environment for fungal growth, warm, humid conditions with abundant organic material. This perfect substrate could have allowed Cordyceps to thrive and mutate more rapidly than in natural settings. While these theories explain how Cordyceps might have evolved to infect humans, questions remain about why this mutation occurred at this specific time. Was it purely environmental pressure, or did human activity, such as deforestation or industrial farming, play a role? The franchise leaves these questions deliberately unanswered, emphasizing the unpredictability of nature and humanity's vulnerability to forces beyond its control. Is there a limit to Cordyceps evolution? The question of whether there's a limit to the Cordyceps fungus evolution in the Last of Us universe is both fascinating and unsettling. The lore suggests that the fungus has already undergone extraordinary adaptations, such as mutating to survive human body temperatures and jumping the species barrier from insects to humans. These changes were likely catalyzed by rising global temperatures, which mirror real-world concerns about fungal pathogens adapting to climate change. However, the extent to which Cordyceps can continue evolving remains an open question. In the series, the fungus demonstrates a remarkable ability to adapt its life cycle to human hosts. It progresses through distinct stages of infection, transforming humans into runners, clickers, bloaters, and shamblers, each with unique traits optimized for survival and propagation. This suggests that Cordyceps is not only parasitic, but also highly opportunistic, modifying its behavior and biology based on environmental conditions and host availability. Speculatively, there may be limits to its evolution. Real-world fungi like Ophiocordyceps unilateralis are highly specialized, infecting only specific insect species. While the fictional Cordyceps has overcome this specialization to infect humans, further adaptations, such as evolving immunity to fire or chemical treatments, might require significant environmental pressure or genetic triggers. Another potential limit could involve the fungus reaching a point of diminishing returns. As it becomes more complex or specialized, it might lose efficiency in spreading or face vulnerabilities in its life cycle. For example, over-reliance on human hosts could reduce its ability to survive without them. Ultimately, while The Last of Us portrays Cordyceps as a nearly unstoppable force of nature, its evolutionary trajectory may depend on environmental factors and the availability of hosts. What is the full mechanism behind Ellie's immunity? Ellie's immunity is one of the most critical mysteries in the Last of Us universe, yet the full biological mechanism behind it remains unexplained. The prevailing theory, revealed in the HBO series, suggests that Ellie's mother, Anna, was bitten by an infected shortly before giving birth. This allowed a small amount of Cordyceps fungus to grow within Ellie during her development, essentially tricking the fungus into perceiving her as already infected. However, this explanation raises scientific questions about how such immunity works, and why Ellie is seemingly unique. One possibility is that the Cordyceps fungus in Ellie's body produces specific chemical signals or proteins that mimic the fungal infection in their hosts. These signals could act as a camouflage, preventing the fungus from attacking her cells. This mechanism might involve changes to her immune system or cellular receptors that make her resistant to fungal invasion. Another speculative explanation is genetic predisposition. Ellie may possess a rare genetic mutation that interacts with Cordyceps in a way that prevents infection. If this mutation is tied to her mother's exposure during childbirth, it raises questions about whether others born under similar circumstances could also develop immunity. It's also unclear whether Ellie's immunity is complete or partial. While she doesn't succumb to infection, she still carries fungal growths within her body, which could have unknown long-term effects. Ultimately, Ellie's immunity remains a tantalizing mystery, one that could hold the key to humanity's survival if explored further in future lore. For now, it underscores the fragile hope of a world dominated by Cordyceps. Could other people be immune? The possibility of other people being immune to the Cordyceps infection in the Last of Us universe is an intriguing yet uncertain question. Ellie's immunity is explained as a result of her mother, Anna, being bitten during childbirth, and the Cordyceps fungus entered Ellie's system through the umbilical cord, growing alongside her from birth and producing chemical messengers that trick the fungus into perceiving her as already infected. This unique scenario raises questions about whether others could develop immunity under similar circumstances or through different mechanisms. From a scientific perspective, immunity to infections can arise through genetic mutations, environmental exposure, or rare biological events. Ellie's case appears to be a combination of timing and biology, a fluke event where her mother's infection coincided with childbirth. Given the specificity of this occurrence, it seems highly improbable that many others would experience the exact same conditions. Anna's bite occurred moments before cutting the umbilical cord, allowing just enough Cordyceps to enter Ellie without overwhelming her system. Such precise timing would be difficult to replicate. However, it is possible that genetic factors played a role in Ellie's immunity. If certain individuals possess genetic mutations that interact with Cordyceps in unique ways, they might also develop resistance to infection. This theory opens the door to the possibility of others being immune without knowing it, especially in cases where they have not been exposed or bitten. Narratively, Ellie's immunity is portrayed as unique and central to the story's themes of hope and sacrifice. The Fireflies explicitly state that they have never encountered anyone like her, despite extensive experimentation on infected individuals. This suggests that immunity is exceedingly rare, if not exclusive to Ellie. From a thematic standpoint, introducing other immune individuals might dilute Ellie's significance within the narrative. Speculatively, future developments in the Last of Us lore could explore whether immunity could arise through genetic predisposition or environmental factors. Do infected retain any human consciousness? The question of whether infected individuals retain any human consciousness in the Last of Us universe is a haunting mystery. The Cordyceps fungus takes over the brain, altering human neurology to prioritize aggression and the need to spread the infection. As the fungus grows, it replaces human tissue and permanently changes the host's body and behavior, seemingly erasing their humanity. However, some moments suggest remnants of human awareness might persist, particularly in the early stages of infection. In the runner stage, the first phase after the infection, infected individuals still appear relatively human, exhibiting jerky movements and anguished screams. This could imply that some part of their mind is aware of their condition but unable to resist the fungal control. Similarly, their violent behavior might be driven not only by fungal programming but also by residual emotions like fear or pain. As infection progresses into advanced stages like clickers or bloaters, any remaining humanity appears to be completely overtaken by fungal growth. These stages show no signs of self-awareness or individuality, as the fungus dominates all aspects of their existence. However, it's unclear if this transformation is absolute, or if traces of consciousness remain buried beneath the fungal control. Speculatively, infected individuals may retain fragments of memory or awareness in early stages, but lose them entirely as the fungus consumes their brain. This chilling possibility underscores the horror of Cordyceps. Victims may experience a fate worse than death, being trapped within their own bodies as they become tools for fungal propagation. How does the hive mind function? The hive mind introduced in the Last of Us HBO series is a fascinating and terrifying evolution of the Cordyceps infection, adding a new dimension to the behavior of the infected. Unlike traditional hive minds often depicted in science fiction, which are centralized around a queen or leader, the Cordyceps fungus operates as a decentralized network. This network is facilitated by fungal tendrils that grow underground and connect infected individuals across vast distances. Tess explains that stepping on a tendril in one location can alert hordes of infected miles away, creating an interconnected system that behaves as a single organism. The mechanism behind this hive mind likely relies on biochemical signals transmitted through the tendrils. In real-world fungi, mycelial networks, often referred to as nature's internet, allow communication between plants and fungi over long distances, sharing nutrients and information. Similarly, Cordyceps may use its tendrils to transmit signals that coordinate infected movements and respond to threats. This decentralized communication system enables the fungus to act as an intelligent entity, optimizing its ability to spread and defend itself. Despite this intriguing concept, there are limitations and unanswered questions about the hive mind. While Tess mentions that the tendrils can connect infected across miles, the maximum range of these connections remains unclear. Additionally, not all infected appear linked to the network. Dry or severed tendrils seem disconnected from the system. It's also uncertain whether advanced stages of infection, such as clickers or bloaters, are more integrated into the hive mind than earlier stages like runners. This decentralized hive mind makes the infected far more unpredictable and dangerous, emphasizing the fungus itself as an intelligent adversary rather than relying solely on its hosts. Why are some infected immobile and fused to surfaces? In the Last of Us universe, some infected individuals become immobile and fused with surfaces, turning into stationary fungal growths that spread spores or tendrils. This phenomenon typically occurs when the Cordyceps fungus fully consumes the host body, leaving them unable to move. Neil Druckmann, co-creator of the franchise, explained that infected often seek dark, moist areas when nearing death, where they settle against walls or corners. Once immobile, the fungus continues to grow outward from their bodies, integrating them into the environment and creating a fungal blanket that spreads across walls, ceilings, and floors. This process allows the Cordyceps to propagate further without relying on active hosts. The mechanism behind this behavior likely stems from the fungus prioritizing survival and reproduction. When a host can no longer serve as a mobile vector for infection due to injuries or advanced fungal growth, Cordyceps repurposes the host body as a stationary spore generator. This ensures that the fungus can continue spreading in areas with favorable conditions for growth. In real-world fungi, similar behavior is observed in parasitic species that use their host as platforms for dispersing spores. Speculatively, this immobility could be influenced by environmental factors. The fungus may detect optimal conditions such as humidity or temperature that trigger its decision to immobilize the host and focus on spreading through spores or tendrils. While these fused infected are no longer a direct threat, their presence creates hazardous zones with fungal contamination, making survival even more challenging for humans navigating such an area. Why did the infection stop contaminating food sources? The cessation of food contamination by the Cordyceps fungus after the initial outbreak is an unexplained aspect of The Last of Us lore. Early in the pandemic, contaminated flour and grain products were identified as key vectors for spreading the infection globally. This mechanism was highly effective, as flour is a staple ingredient in countless food items consumed daily. However, after society collapses, there's no indication that survivors face ongoing risks from infected crops or processed food, raising questions about why food contamination stop. One speculative explanation is that the Cordyceps fungus exhausted its ability to infiltrate food systems due to the collapse of industrial agriculture and global supply chains. With factories shut down and mass production halted, the fungus may have lost access to large-scale distribution networks, forcing it to rely on direct human transmission, e.g. bites or tendrils. Alternatively, Cordyceps might have evolved away from food contamination as its primary strategy for spreading. Once the infection reached a critical mass in human hosts, it may have prioritized person-to-person transmission, which is faster and more efficient in a fragmented society. Another theory could involve survivors adapting their food systems. Many people have learned to avoid contaminated sources, or develop methods for detecting and eliminating fungal spores in crops and supplies. That brings us to the end of the video. The Last of Us Season 2 has already started airing, and we're hoping to see some great storytelling and zombie action. See you in the next one. Be safe and be marvelous. And if you liked our content, don't forget to leave a like and subscribe to us if you haven't already. Have a good one and be safe. Thanks, everyone.